Hello everyone, welcome back to our channel. In today's session, we'll dive into Terraform State Locking using DynamoDB with Lock ID and an S3 bucket. So we are going to explore how this combination will ensure safe and concurrent infrastructure modification in a collaborative environment. So today we are going to learn the state file of Terraform. Then what is the purpose of the state file in Terraform? What is AWS S3 and DynamoDB service? Then there are some prerequisites you should need to follow in this tutorial, which is you need to have an AWS Prettier account. Then we should have AWS CLI configured with the administrative privileges. Then Terraform should be installed on your local system. So these were the prerequisites. Then we will learn about some example of Terraform state file. Then we will see what are these categories of state file like local and remote. So what's the use of local and remote, and we will learn about Terraform remote state and state log. Then we will perform a practical and we will see the steps for managing remote state file using S3 and DynamoDB. So these steps include like creating S3 bucket using Terraform, creating DynamoDB table. Then we will create a Terraform backend configuration, which we will learn two methods how we can declare the backend configuration in Terraform. So there are two methods. So method one, we will learn about how we can add configuration block inside the Terraform code and how we can dynamic backend parameters with the Terraform init. How we can use dynamic backend parameters with Terraform init command. Then finally, we will see this Terraform state versioning by testing it. And then we will conclude for today. So let's start. So what is exactly Terraform state file? So the Terraform state file, typically named as terraform.tfstate, is a crucial artifact that stores the current state of deployed infrastructure. It contains a snapshot of resource attributes and the relationships as defined in the Terraform configuration. So basically, this file enables Terraform to track changes synchronized with the actual infrastructure and facilitate accurate updates or modification when the configuration evolves. The proper management of the state file is essential for maintaining consistency and ensuring effective collaboration in infrastructure as code project. So what's the purpose of the state file in Terraform? So the Terraform state file maintains the current state of managed infrastructure, enabling accurate tracking, preventing concurrent conflicts, and facilitating recovery and rollbacks in case of error. So it also stores resource metadata and output values for effective resource management. So let's understand some key purpose of state file in Terraform. So for example, state tracking. So it keeps track of the current state of managed infrastructure resources. It can also be for concurrency control, which prevent conflicts by locking the state during concurrent operation. Then it can also be helpful for output values to record the current values of defined outputs for querying post-deployment. And with the help of state file, we can recover, which facilitates recovery from errors and rollbacks by storing previous infrastructure state. So now as we are using the services called as AWS S3 and DynamoDB. So let's understand what is AWS S3. So AWS S3, so its full form is Simple Storage Service. So it is a scalable object storage service provided by AWS. So it allows you to store and retrieve any amount of data from anywhere on the web. So S3 is commonly used for storing backups, media files, static assets for website and data. So for example, you can use AWS S3 to store images for your web application, and your application can upload images to an S3 bucket and users can download these images from the bucket when viewing your website. Now let's learn about DynamoDB. So DynamoDB service is a fully managed NoSQL database service provided by AWS. So it is designed for applications that require low latency and seamless scalability. So DynamoDB is known for its performance, reliability, and atomic scaling capabilities. So let's take an example. Suppose you can use DynamoDB to store user data for mobile app. So the app can store user profile preferences and other information in the DynamoDB table. And a DynamoDB will automatically scale to handle increasing load as the app gains more users. So these are the services we are going to use today. Now let's understand the example of the Terraform state file. So basically I am using Terraform to let's take an example to set up an EC2 instance. So as an example to better understand how the state files work. So this is the article which is available on posttechnics.com. So you can refer this for Terraform code and other configuration. So let's take an example of EC2 instance. Let's see what is the state file. So first, you need to create a main.tf file. So let's move to our Terraform Visual Studio Code. So here you can find that I have created one main.tf file. So ignore all this. So first, you need to create main.tf file. And in this main.tf file, I am going to launch simply a EC2 instance where I have named it as Terraform State Test. Here you can find the state test. And so we will comment out here the tag name. So simply I am creating the EC2 instance with the AMI ID of Ubuntu. So I am creating an Ubuntu instance with the instance type as t2.micro. So this is eligible for free tier account. And simply I have mentioned here the key name. So with the help of the key, we can access this EC2 instance. And at start, I have just provided the provider block. So I am using AWS as my provider. The region I am currently using is AP South 1. And the profile is set to default where I have mentioned my access key and secret key. So you can configure this with the AWS CLI. Then simply I have mentioned the required provider block and the version I am currently using is 5.4.0. So now we will simply save this file. And now simply I will click on this, open the integrated terminal. So I have make an directory called as Terraform managing state file using S3 and DynamoDB. And in that I have make another directory called as EC2 instance. And in that I have make one file called as main.tf. So simply now I will initialize this Terraform code. So simply type your Terraform init command to initialize. So it will initialize all the backend and provider plugins. So we have successfully initialized. Now we will clear this. Now simply type Terraform plan. So let's check what are the resources we are going to create on our AWS account. So as we do Terraform plan, here you can find the terraform.tf state file have been created. Now let's apply to see the terraform.tf state file. So simply clear this, and here you can find one resource to add it. So which is our EC2 instance. So let's type here Terraform, apply with auto approve. So it will automatically give the permission to apply for this. So here you can find that it has been the creating state. For EC2 instance is in creating state. So here you can see our apply has been completed and one resource have been added successfully, which is the EC2 install. And here you can find below the main.tf file, here you can find the terraform.tf file, tf state file. So if you click on this, so let's view what's inside the state file. So here you can find terraform.tf state file consists the AMI ID, which will consist all the record. And here you can also see it storing the private IP, the public IP, and all other details. So this is just an example that how the terraform.tf file should look. Here you can find the name. So it is basically just to keep the record of our Terraform EC2 instance, which we have applied. Now, now we have seen the Terraform state file example. So basically after we apply our configuration in Terraform, so then only our state file is visible. Now, let's understand what is Terraform remote state and state lock. So basically why state lock is necessary. So, so this Terraform dot tf state file is on our local system now. So we have not used S3 bucket to store the tf state file or anything like that. So this is in our local system. So this is called as local remote state file. Sorry, local state file. Now let's see the Terraform remote state and state log. So Terraform remote state refers to storing Terraform state file, so which contains the current state of your infrastructure remotely rather than locally on our machine. So this will allow for collaboration among team members and ensure consistent state management across environments. So basically, state locking is a mechanism that prevents concurrent modification to the state file, which will ensure data integrity and avoid conflicts in collaborative environments. So let's take an example. So imagine you have a Terraform project deployed in the AWS. So instead of storing the state file on your local machine, you can configure Terraform to store it remotely using the S3 bucket and use DynamoDB for state locking. So this setup will ensure that all team members have access to the latest state of the infrastructure and prevent simultaneous changes that could lead to the conflict. So for example, when the developer X executes the Terraform code, so DynamoDB will lock the state and developer Y should wait until the execution is completed. Let's take another example. Suppose if your desired state, initially there are 3 servers deployed on AWS and the goal is to reach total of 5 servers. Now let's understand the stateful Terraform. So with Terraform and a maintained state file, Terraform knows about the existing 3 servers. So when instructed to deploy 5 servers, it adds only the required 2 servers to reach the desired state. Now imagine if you are not having the stateless file. So in this scenario, if the state file is lost or inaccessible, Terraform becomes stateless. So in this case, if instructed to deploy 5 servers again, the Terraform lacks the information about the existing 3 servers. So it ends up deploying 5 new servers, resulting in 8 servers in total, which exceeds the desired state. So basically, what's the difference between the stateful versus the stateless? So being stateful means Terraform remembers the existing infrastructure configuration, ensuring it makes only necessary changes to reach the desired state. And being stateless means Terraform lacks its memory and may deploy resources without considering existing configuration. So basically, to avoid such issues, we use remote state storage and locking mechanism with Terraform, so which is crucial. So this setup will ensure that Terraform maintains a consistent and accurate view of the infrastructure state, preventing unintended changes like deploying extra servers. So these were the examples. Now let's move practically that how we can store our remote state file, our local state file to remote state file using S3 and DynamoDB service. So let's go to our article. So here you can find the summary view of our Terraform file. So I have created one directory called as Terraform managing state file, and here I have created directories. Here I have created three directories called as DynamoDB, EC2 instance, and S3 bucket. So three directories I have created. So first step is to create an S3 bucket using Terraform. So here you can find that I have already created S3 bucket. In the directory, I have created S3 bucket.tf file. So let's create an S3 bucket. So basically, utilizing a remote backend for the state file offers significant benefits, including built-in encryption and versioning capabilities. So to create S3 bucket, you can find this code in our article. Here you can find the below is the Terraform code snippet to provision an S3 bucket with versioning enabled to safeguard the state file from accidental overrides. So now we will simply copy this code and paste it in the Terraform state file. Sorry, paste it in the s3 bucket.tf file. So here you can find the code. So simply paste here. Now we will simply click on the S3 bucket directory and open in an integrated terminal. So let's first destroy the EC2 instance which we have created earlier. So just enter your Terraform destroy command, so it will destroy the resource of EC2 which we have created earlier. Now here, as I have pasted the code here, so let's understand this code. So first, here you can find the provider block where we are currently using AWS as a provider, as we are using AWS S3 bucket. The region which I am currently using is AP South 1, and profile is set to default where I have configured AWS with my access key and security. Then simply the Terraform required provider block where the source and version I have mentioned here, the AWS block, and simply here you can find the code to create the S3 bucket. So as you need to create the S3 bucket, so I am currently using the resource name as AWS S3 bucket to create S3 bucket. So basically, an AWS S3 bucket resource name as Terraform State unique bucket that Terraform will manage. And here you need to mention your bucket name. In this bucket, I have mentioned the bucket name as Terraform State unique bucket. So you need to require a unique name for the S3 bucket to create S3 bucket. Then I have mentioned as force destroy. So basically, this will allow Terraform to destroy the S3 bucket even if it contains object. So use this carefully. Now, so basically, in next block, I have enabled the S3 bucket versioning. So basically to enable, I have taken the resource name as AWS S3 bucket versioning, where it will define an AWS S3 bucket versioning configuration for the previously created bucket. And simply you need to specify here the bucket name with the first resource name, then the name of the bucket and .id. So this will enable the bucket versioning for the bucket which you are going to create, which is Terraform State Unique bucket. And below this, here you can find the versioning configuration status is enabled. So this will enable the versioning for the S3 bucket to store multiple versions of the object. So basically, in summary, this Terraform code sets up an S3 bucket named as Terraform State Unique bucket in the AP South 1 AWS region with versioning enabled. So this bucket is intended to store the Terraform state file, so ensuring that different versions of the state file are retained, providing a history of changes made through Terraform. So that's why we are using AWS S3 bucket versioning. Now let's check. So I have destroyed the previous EC2 instance. Now let's apply this configuration. So save this configuration of S3 bucket and simply click on Open Integrated Terminal. So here you can find I have stored the S3 bucket.tf file in the S3 bucket directory. So first, simply initialize. To initialize, simply type Terraform init command. Now Terraform configuration has been successfully initialized. Then simply enter your Terraform plan to check whether we have any error or what are the resources which we are going to create on our AWS. So here you can find two resources to be added. So one is the S3 bucket and versioning state. So now we will simply type here Terraform apply for applying our configuration in the AWS with the auto approve. So which will automatically approve create resource. So here you can find that this is the creating state and our apply has been completed and two resources have been added, 0 to change and 0 to restore. Now we will verify this on our AWS account. So let's move to our AWS console. So here you can find all these services. So you can simply search here S3 and simply click on S3. And here you can find we have successfully created the Terraform State Unique bucket. And if you click on this, so simply enable the option of show version. Now initially there are no state file here as we have only created bucket now. So we have successfully created bucket. Now let's check our next step. So the next step is to create a DynamoDB table. So now we'll create a DynamoDB table. So simply let's move on to our Visual Studio Code. Now we have finished with the S3 bucket. Simply I have created another directory named DynamoDB, and in this I have simply created a file called as DynamoDB table. Just simply use my article for the code. Simply copy the code and paste it in the Visual Studio Code editor. So first we have created S3 bucket. Then now we are going to next step, which we are going to create DynamoDB table. So this block is similar to the previous one where I have used the provider block and Terraform. So now let's check this block. So basically, this Terraform code will define an AWS DynamoDB table resource for managing state locking, typically used in Terraform configuration to prevent concurrent updates from multiple users or processes. So to create Dynamo table, we need to use resource name as DynamoDB table, AWS DynamoDB table, and I have declared an AWS DynamoDB table resource named as state lock table that Terraform will manage. And simply I have given the name for the Dynamo table DB table as Terraform State Unique Lock. And here you can find the billing mode is set to pay per request. So basically, this means you are charged based on the number of read or write operations rather than the provision capacity. Then I have used the hash key. So basically, this will define the hash key for the DynamoDB table as lock ID. And the hash key is used for data partitioning and uniquely identifies each item in the table. And here you can find the attribute block, which will define attributes for the DynamoDB table. So the name is lock ID. So the name is lock ID, which specifies the name of the attribute as lock ID, which matches the hash key defined earlier. And the type is set to S, which is set to the data type of the attribute to string S. So in summary, basically, this Terraform code creates a DynamoDB table called as Terraform State Unique Lock with a hash key lock ID of type string. And this table is typically used for state locking in Terraform to manage concurrent access to the state file, which will ensure that only one user or process can modify the state at a time to prevent conflicts and data corruption. Now we will proceed this by initializing and deploying the Terraform code to implement this configuration. So now simply click on DynamoDB, right click on DynamoDB and open an integrated terminal. Now simply type the Terraform init command to initialize backend provider plugin. So we have successfully initialized. Now we will apply a configuration. Now by applying this will create DynamoDB table in a AWS account. So here you can find the DynamoDB will be created and it has been created successfully. Now we will verify this on a AWS account. So simply create one duplicate tab here and simply search here DynamoDB. Now as we have created table, so simply click on your table and here you can find we have successfully created table called as Terraform State Unique Lock. Now let's move to our next step. Now, so these are the main steps. So to create Terraform backend configuration. So basically, now that we have set up with the S3 bucket and DynamoDB table, we can process to test our remote state management using an EC2 provisioning example in Terraform. So basically, there are multiple approaches to implement remote state in our Terraform configuration. So let's explore each method in detail. So first method here you can find is to add configuration block inside the Terraform code. So let's move on to our Visual Studio Code editor and simply click on EC2 instance, and here our main.tf file is stored. So here you can find the code. So method one says that we need to add configuration block inside our Terraform code. So simply we will refer to our article. So here you can find the black fold which consists the configuration of the backend. So simply we will copy this and paste it in our main.tf file and save this file. So now we are going to create an EC2 instance, so that will create a Terraform state file, and that Terraform state file, when we create EC2 instance, will be stored in the S3 bucket, and using the DynamoDB we can lock the state file. So method we have learned that we are adding the configuration block, so basically inside the Terraform code. So just we have add this configuration. So basically here you can find the Terraform block, which is used to configure Terraform specific settings like backend configuration. So basically to set up the backend S3, which will specify that Terraform should use the AWS S3 backend for storing the state file. And you need to mention here the bucket name, which is we have created, which is Terraform State Unique Bucket, which will specify the name of the S3 bucket where the state file will be stored. And also you need to specify the DynamoDB table, which will specify the name of the table used for state locking. So which is Terraform State Unique Lock. So this will ensure that only one user or process can modify the state at a time, preventing conflict. And the region I am currently using is AP South 1. And the key, so basically we need to specify the key path within the S3 bucket where the state file will be stored. So in this case, the state file will be named as ec2.tf state and stored in the stack folder within the bucket. So stack folder is just an environment I'm using as staging. So there are multiple environments like development, testing, and staging. So I'm just given the directory name as staging. So in the within the bucket, it will create one directory called as stack, and then it will store the ec2.tf state file. And the encryption is set to true, which will enable encryption for the state file stored in S3, ensuring that the state file is encrypted at rest. So basically, in summary, so this Terraform configuration sets up S3 backend for storing the Terraform state file with encryption enabled. So it also utilizes DynamoDB for state locking, which will ensure safe and concurrent access to the state file when multiple user or process are working with the Terraform. Now, let's proceed to deploy an EC2 instance using this configuration with the S3 backend and state locking enabled to validate the remote state management. So now we will apply this configuration. So we have already opened the terminal of EC2 instance. So now we will initialize it. To initialize the backend first, so simply type a Terraform init. So here you can find it is initializing the backend, and here you can find the message which consists of successfully configured the backend S3. So Terraform will automatically use this backend configuration. So now we will let's plan this configuration to check the resources which we are going to create. So here you can find one resource to add, which is the EC2 instance, and simply then we will apply this configuration. Simply type here yes. So it will proceed further and apply a configuration on my AWS account. So here you can find that the creation has been complete, but it have taken 1 minute 14 seconds. And successfully we have created EC2 instance. Now we will verify this. So simply I have created a duplicate tab. Simply search at EC2, click on EC2 and just click on instances. And here you can find our instance have been created successfully. So if you click on this, all the details like public IP, private IP, we can see these details. So now let's go back to our S3 bucket. Now just we will refresh this. We will also refresh the DynamoDB table. So here you can find that our terraform.tf state file is being stored in the stack directory, but the name here I have used as ec2.tf state file. So here you can find that Terraform will update the current state in the bucket as a new file. Now, to view the lock entry data in the DynamoDB table, so simply explore the table item. So simply click on explore items and click here. So here you can find the lock ID. So this will allow you to inspect and manage the state locking information directly from the DynamoDB console. So we have successfully stored the ec2.tf state file here for the backup, as well as we have used DynamoDB for the lock. Now, let's take our next step. So as we have finished with the first method, you can destroy all the resources. As we are going to learn with the second method. So simply Terraform, enter here. To clean up, simply click here Terraform, destroy. So one by one, you need to destroy all the resources. So simply type Terraform destroy to destroy the resources. And here you can find, simply type yes. Now let's go to our second terminal, which is S3 bucket. Here you can find S3 bucket. Now simply Terraform destroy. And similar to the DynamoDB. So enter the value, which is yes. So it will destroy the resources, as well as enter here to destroy the DynamoDB. So here you can find our EC2 has been destroyed successfully. You can verify. So if you refresh this, the status will be shown as terminated. Here you can find the state which is terminated. Now let's check our resources have been deleted. So here you can find our S3 bucket and versioning has been deleted, and also the DynamoDB table. Now let's check the second method. So second method is to declare the dynamic backend parameters with the Terraform init command. So basically, in real world project, dynamically passing backend parameters in Terraform configuration is essential for flexibility. So by doing so, you can adjust the remote state file using file location, environment names, and other parameters at a runtime based on specific requirements. So simply, you can add the backend block in the Terraform configuration file with the only backend type specified. So let's add simply in our configuration. So this is our main.tf file. So we will comment out this. So we will save this file and we'll refer the article to simply add the backend configuration. Now simply paste here and save this file. So here basically this is also the backend block. So this block will use to configure Terraform specific settings like backend configuration, which is backend S3, which specify that Terraform should use the AWS S3 backend for storing the state file. And you be careful, you need to specify a region. So region I am currently using as AP South 1. So where the S3 bucket for storing the state file is located. So basically, in summary, so this Terraform configuration block sets up S3 backend for storing the Terraform state file in the AP South 1 region. So as in previously, we have specified all the bucket name and etc. So we will just type, as it is not safe to enter all the bucket name DynamoDB here. So we will just do Terraform init and then we will specify all the configuration by just applying the Terraform init command. So this additional configuration can be included based on your specific requirements using the appropriate parameters within the S3 block. Now the remaining backend information will be given with the Terraform initialization command, as this is our second method. So first, let's again apply to our S3 bucket. So simply Terraform, type your apply command. So simply I have showed you that how we can destroy the resources. That's why I have destroyed earlier. Now simply also apply to our DynamoDB configuration. So let's check. So our S3 bucket have been created successfully as well as our DynamoDB table. Now let's perform. So simply open an integrated terminal of EC2 instance where our main.tf file is stored and we have provided the backend configuration. So simply now initialize with Terraform init and hyphen migrate state. So basically this command is used to migrate the Terraform state from a previous backend configuration to a new backend configuration. So after the initialization, we can directly perform Terraform apply or Terraform destroy command. So simply click on enter, and here as we are specifying the after the configuration Terraform init command, so simply you need to enter the name of the S3 bucket. So here simply we will copy this from. So the name of the S3 bucket is Terraform State Unique Bucket, and we will enter. Then again you need to specify the path to the state file inside the bucket. Simply it is stack ec2.tf state and press enter. So here you can find that we have successfully configured with the backend S3. Terraform will automatically use this backend configuration. So now we will just apply this configuration, Terraform, apply, and simply type yes. So we have used two methods. So first method, we have directly added configuration block inside our Terraform code, and then we have simply used the method 2 by dynamically using backend parameters with the Terraform init command. So the method you can use according to your requirement. Now let's move for editor. So here you can find our apply has been completed. So we have finished with the steps, and we have seen two methods successfully. Now our next step is to check the Terraform state version. Now simply we will perform. So now we have stored the Terraform state file for the EC2 deployment is the S3 bucket. So you can check this. So we will verify again. So here you can find the EC2 state df.file, and also you can refresh this, and also click on instances, and here you can find our instance have been created successfully, as well as the DynamoDB table. As well as with the S3 bucket. Now to demonstrate the state versioning, we'll make a modification in our EC2 resources by just simply adding the tag name. So that's why I have comment out the tag name. So simply control plus slash. So I have commented it and just save this. Now in here you can find the instance. We have not specified the instance tag name. So now we will just apply this configuration, and we will check the state file. So basically now we will initialize and apply the Terraform code first. Terraform apply command. So it will show that only we need to add the tag name. So here you can find only will be updated just the tag name, which is Terraform State Test. And simply click on yes. So basically this will, so we have modification are complete in one change. So we will verify this first. Now here you can find the instance name. So what this will do is that the state file will be modified, and we can check the state file version from the, so if you refresh this, so here you can find the change which we have added. So because of enabling version, it will allow easy for retrieval of previous state version when needed. So this will enhance state file management in the AWS S3. So that's why we have enabled the version. So we have successfully performed the practical and seen how we can manage the remote state file by using S3 and Amazon DynamoDB. So you can refer the article which is available on costexcuse.com. So we will conclude for today. So in conclusion, Terraform state locking using DynamoDB, block ID, and S3 bucket provides robust concurrency control and data integrity, which is essential for collaborative and production environment. So again, for reference, you can visit the official website, which is posttechnics.com, and you can find the related articles just like how to create VPC in AWS using Terraform. And you can also use our YouTube to see how we can create VPC in AWS using Terraform. So thank you for watching my video, and please do like and share the video, and don't forget to subscribe our channel. Thank you again and see you in the next video.